Hi, welcome back. This is Ms. Mornow, and we will continue our discussion of matter. So now we're going to look at properties of matter. So we have different properties. We have physical property, which is a characteristic that is observed without changing the chemical makeup of the substance. Some examples would be mass, volume, and color. And notice all these measurements here of mass and volume has a unit associated with it. Physical properties, there are two types of physical properties. You can have an extensive property or an intensive property. The difference is an extensive depends on the amount you have. So when you measure it, you could take some, say some salt, and the mass of the salt would depend on how much salt you actually have. The volume, the same thing. And intensive does not matter how much you have, that property is going to stay the same. So the salt is white. It doesn't matter if you have a little bit or a lot. The melting point, we talked about the melting point of water being 0 degrees. It freezes and melts at 0 degrees. Doesn't matter if you have a little or a lot, it's still 0 degrees. The density of water is 1.0 grams per milliliter. It doesn't matter if you have a little bit of water or a bucket of water, it's still going to be the same. And specific heat as well. And we'll talk about specific heat a little bit later, but that's the amount of heat it takes to raise 1 gram of a substance 1 degree Celsius. Okay. Right, some examples. Extensive, if you have 2 gold bars, the mass is now 2 kilograms of gold. Okay, so if you look at this, let me see, 1 kilogram, and if you have 2 of them, then you're going to have 2 kilograms. Okay, I see. Intensive, let me move this a little bit out of the way. It doesn't matter if you have 1 gold bar or 2 gold bars. They're still the color gold. Whenever you record data in class in any lab, we want you to always think about whether that data is intensive or extensive. Chemical properties is a characteristic that is observed when the substance undergoes a chemical change, reaction. These properties show how a substance reacts with other substances. So example, iron reacts with oxygen to form rust, would be a chemical property. Reacts with hot water or steam to produce, you're getting something new, that would be a chemical property there, and dissolves in most acid would also be a chemical property. You'll need to be able to distinguish between chemical and physical properties. So the density of water near room temperature is 1.00 gram per cubic centimeter, and remember earlier I wrote 1.0 grams per milliliter, but remember 1 milliliter is the same as 1 cubic centimeter, and we expect you to remember that. Anything that is more dense, oh, and just that density is a ratio of mass to volume. So anything that's more dense than 1.0 will sink in water. Anything less dense will float. And it says arrange these 3 layers. Actually, they're already arranged here. The more dense is always going to be on bottom, with the least dense being on top. Viscosity is a term related to fluids. It's the resistance of flow. Okay, so something that moves, that flows very slowly is going to be very viscous. Okay, and things that flow very quickly are less viscous. And that viscosity has to do with intermolecular forces that we're going to cover in a later unit. Then we also have changes in matter. We have physical changes and chemical changes. This slide focuses on physical change. It's a change that does not produce a new substance. Okay, so phase change. You know, any kind of phase change. Phase changes being melting, freezing, condensation, boiling, deposition, sublimation. Those are all physical changes because they only involve the substance changing between the states. It doesn't change what the substance is. So in all of these, solid, liquid, gas, you can have ice. You have liquid, you can have, looks like some type of cloud of some sort here, I guess, but it's all still water, H2O. Changes in form. So when you dissolve sugar in water, you still have sugar in water. So that would be physical. Crush an aluminum can. After it's crushed, it's still can. Sculpting clay. After you sculpt it, it's still clay. Mashing potatoes. When you're done, still potatoes. And then forming any kind of mixture will be physical change. Changes in state of matter of a substance, they're always physical changes. So this is going to focus, these are those phase changes that I was mentioning to you just a moment ago. Make sure you know these. Melting is going from a solid to a liquid. Now heat flow, remember I told you heat will always flow from warm objects to cool objects. In this case, we're just saying what happens. So if you go from a solid, which has less energy, to more energy, the only way that could have happened is it absorbed. This referring back to the previous video, we talked about the energy associated with states of matter. And so anytime energy is being absorbed, we call that endothermic. Okay, so endothermic, energy being absorbed. Exothermic, energy is released. Okay, so let's see, freezing. Okay, well, let's think about the states of matter. Freezing goes from a liquid to a solid. Which one of these has the most gas, or excuse me, not gas, energy? So we're going from more energy to less energy. And the only way that could happen is if energy was released. Oops, sorry about that. Released. And when it's released, we call that exothermic. Boiling is, think about the state, it's going from a liquid to a gas. So that's going from less energy to more energy. And the only way it could end up with more energy is if energy was absorbed, and when energy is absorbed, it's endothermic. Condensation or condensing is going from a gas to a liquid. This is going from more energy to less energy. And the only way you could end up with less energy is if energy was released. And when energy is released, that's exothermic. And give you just a moment to do sublimation and deposition. We look at that, solid to a gas, absorbed, endothermic. And then for deposition, from a gas to a solid, it's going to be released, and it's going to be exothermic. These two that are asterisk are the ones students tend to mess up with the most, and that's because you're probably most familiar with these states, these phase changes. Make sure to pay special attention to those and make sure you know what they are. Sublimation is a solid to a gas without passing through the liquid phase. Okay? Examples of that is dry ice, air fresheners, mothballs. Deposition is going from a gas to a solid without passing through the liquid. So frost on a windshield, water vapor in the air crystallizes on the cold glass. Let's see. Don't know it. No, that video is not going to work. All right, so here's some phase changes here. So when we go from a solid to a gas, okay, we said that was going to be called sublimation. Okay, and we go from a gas to a solid, we call that deposition. Okay, we go from a solid to a liquid, we call that melting. When we go from a liquid to a solid, we call that freezing. When we go from a gas to a liquid, we call that condensation. And we go from a liquid to a gas, we call that boiling, vaporization, and then evaporation if it occurs at the surface. Okay. Chemical change, a change that does produce a new substance, also called chemical reaction. So you have here, you have soured milk. You have, it says a hot gas formed when hydrogen, that's not a phase change just because you see the word gas, but since that gas was formed from hydrogen and oxygen, you get a new substance. Okay, interaction with carbon dioxide and water has formed a new substance. That would be chemical reaction. And then you have the bubbling there, which indicates something's up. It says not just that it's bubbling, but that citric acid and baking soda are reacting there. One rule of thumb that can be useful in distinguishing physical from chemical changes, ask yourself, can the change be reversed? If yes, probably physical. If no, probably chemical. Milk sour, can the change be reversed? No. Doesn't taste the same, it's chemical. An ice cube melts, can it be reversed? Yes, because you can freeze it, so it's a physical change. But you want to be careful with this. It's not perfect. For example, if you consider change that takes place when paper is cut into pieces, can you get the whole sheet back? No. But what kind of change it is, it's still physical. So we use that just as a rule of thumb, not the rule. Okay. These are the indications that a chemical reactions happen. We expect for you to know this. A gas is produced. How would you know that? You could see bubbling, fizzing. You could actually, if it's a colored gas, you may be able to see it. If there's a distinct smell, you might be able to smell it, but you would do that more often. Light's produced. A solid precipitate is formed from two solutions. We expect you know what a precipitate is. It's a solid formed from two solutions. Temperature change. Temperature goes up. Exothermic energy was released. If the temperature goes down, it's endothermic. Right? And then the permanent color change. Let's see. I don't think this slide's going to work. An example of an exo, so we talked about endothermic, exothermic in terms of chemical changes. And exothermic, you have energy that is released. You could actually feel that it gets hot. And endothermic, energy is gained, and you would actually feel cold. So some examples of that would be a log burning and one of those chemical cold packs. Here's just some vocabulary that we'd like for you to start knowing. The starting materials in a reaction are called the reactants. The ending materials are called the products. And there's an arrow that separates. So these would be the reactants. These would be the products. And this arrow here, okay, is a yield sign. So these are the components. You have reactants, yield, products. Reactants are on the left, products are on the right. And it reads just like a sentence. The law of conservation of mass is that mass cannot, matter is conserved, it cannot be created or destroyed. So however many atoms you start out with, that's how many atoms you're going to end up with. Whatever mass you start out with, that's how much mass you're going to have in the end. All of the original atoms that were in the reactants will be present in the products. For a chemical reaction to be balanced, the total number of atoms of each element to the left of the arrow must equal to the total number of arrows to the right. So if you look here, you have 6 carbon, 6 carbon. You have 12 plus 6 oxygen, so that's 18. And over here you have 12 plus 6 is 18, and then you have 6 and 2 is 12. And then over here, you have 12 hydrogen. We'll get into balancing these in another unit, but I just want to kind of show you that a little bit. So if we look at this, if you start out with 264 grams of carbon dioxide, 108 grams of water, and you end up with 180 grams of the sugar, how much oxygen is there? Well, you know that these sides have to be equal to each other. So whatever this is has to equal this. So we could add these up together, and we could subtract out that, and you should see that you should get 192 grams of oxygen. Provide the following masses, solve the mass for the mass of magnesium. So when you look at this, if you add these, this number should equal this side's number. So you do 95 plus 2, it's 97. And so this side is X. So you just subtract out that, and you should get the answer of 24. And it is 24. Okay. All right, that's the end of this unit, actually. We hope you've enjoyed your first unit in chemistry, and we look forward to seeing you in class tomorrow with any questions.